Hello, everyone. Welcome to the second day of PyData Amsterdam. Our next speaker is Vincent D. Warmerdam, and he was one of the co-founders of PyData Amsterdam. He contributes to the data science space in many ways. As an educator, he communicates data science topics in different media. He is the creator of several widely used open source libraries, with some of them with more than 2 million downloads. Today he's going to talk about a new generation of Python notebooks that can supercharge the work of Python developers and data scientists. For the newcomers, please, you can come and sit in the front. There's plenty of space. And let's give a warm welcome to Vincent.
Talk to me, talk to me, baby. I'm going up from this sweet baby. Whoa.
All right. Hi, everyone. This is a notebook. It is titled Untitled13, and you can see that there is some code in it. And it's a relatively simple notebook. You can see that the first cell over here has x is equal to 1. The second cell over here has x is equal to 2. And this third cell over here has x plus y. Close your eyes for a moment and tell me what x plus y is equal to. Well, obviously, it's equal to 13. The reason why you're seeing 13 here is because I can do things like this. Like I can say, actually, x is equal to 12 here, and then I can just sneakily delete this cell, and then I can kind of fool everyone by having a representation that's in memory that's different from what you're seeing on screen. And this is always a thing with notebooks, or Jupyter notebooks, I should say. There's reasons for it, but this is always, in my mind, a source of errors. You typically have this thing with data frames where, like, oh, I changed the data frame in this one cell over here, then I make a chart there, I delete this cell over here, and then there's no warning, but then, oh, it's still in memory, so the notebook's not going to complain about it until I restart it, and then I can't run it anymore. And there's always been this phenomenon where if you're used to notebooks, it's typically fine, but you got to train yourself in this phenomenon that what you're seeing on display is not what's in memory right now. And there's reasons for it being this way. Another thing that I also want to mention is that Jupyter is still kind of an amazing project, right? If I think about all the algorithmic discoveries in the past 10 years, if we didn't have a notebook at our disposal, just fool around with stuff like, I think famously, clip embeddings would not have existed. Like, all of that research was done in the Jupyter notebook. Jupyter is also really cool because it wants to do more than just one language, right? Like, it wants to allow for JavaScript, for R, for Julia. It's like a multi-language phenomenon. But you could wonder, if we just care about a notebook just for Python, what if we change a few things? Like, can we make this one phenomenon maybe go away? And if you want to do that right, what are the consequences? And as we're going to see in a moment, I work at a company called Marimo. I'm going to show you the Marimo notebook. We have a way of thinking about this problem that I want to show. What I do want to warn you for is that it is going to feel a bit different in the first 15 minutes or so. That's like the one mental thing I want to point out. But having said that, I'm now going to try to do the same thing. I'm going to try to fool you again, but now in a Marimo notebook, and we're going to see what happens. So, bye-bye Untitled13. I have Marimo over here. That's from the command line. And one of the features that I do really love about it is that I can say Marimo edit, and I'm going to do that in sandbox mode. I'll show you in a moment why. And then I have to name a file now, so I can do demo.py. And at least now, I don't have an untitled file, so that's also just kind of nice. And then here we are in a Marimo notebook. And let me just make this compact. That's kind of nice on display. Just importing Marimo because there's some utilities. And once again, it feels like a notebook because we have cells at our disposal. So again, x is equal to 1, y is equal to 2, x plus y is equal to 3. And now I'm going to do x is equal to 11. Blah. Won't do it. Not allowed whatsoever. So OK, it's going to complain about this. Another thing that's also going to happen in this notebook environment that's different than what you're used to, and it's related, I can change this one cell on top over here. And I want to have you pay attention. I'm about to click this button over here that's going to play that cell. And I would like you to pay attention to what's happening to this number as I do that. So again, I'm going to click this button. Oop. It automatically updates. So I don't have to like go up, run the cell, go down again, run the cell again, because the game we're playing here is that what you see on screen is the valid representation in memory. And the way it works internally is it's kind of like a DAG. So you can imagine that from the perspective of this cell over here, let's make you draw stay. From the perspective of this cell, it's going to go, well, if I want to run, I need to have x, I need to have y. Where is x? Where is y? And then we can do a pass on all of the cells, almost like a compilation step beforehand. And we can say, well, oh, actually, x is defined over here, so that's a parent. And y is defined over here, so that's a parent. And then if this cell updates, all of its children automatically have to update as well. We can figure out what nodes we have to run again. And this is also a nice little mechanism such that if I were now maybe to delete this cell, for example, it's again going to complain because it's saying, look, yo, in your face, x is missing, I can't run anymore. Another thing you're going to notice that's different in this environment is that we still have cells, but there's all these buttons on the side. And one of these buttons looks like a DAG. And what you're actually able to do is you can have this vertical view. Let me just zoom in a bit. And you can actually see these dependencies between these different cells. Another thing we have, which is a relatively new feature, is we also have this mini-map. So I can be on a cell over here. There you can see, oh, where are these variables defined? So like when you're debugging and you don't know in what cell you define the thing, you can easily sort of find your way around. But I just want to talk about some consequences of this, because the order of the cells really doesn't matter anymore. So, oh, that's kind of cool, because that means that I can move my imports all the way at the bottom, actually. Like, it's not the main dish, so why on earth would I start with that? And, oh, I can actually maybe move the thing that really matters on top. And, oh, that's actually just kind of nice. So these are all sort of benefits, but we are doing a very un-Python thing as well at the same time, because I'm also not allowed to do stuff like this. I can't do x plus equals 10 here. And that's because, from the perspective of this cell on top, I don't know what the value of x is. Like, if I allow for in-place updates and I allow for more than one, then what cell has to run before? Oh, we have to make assumptions, and that's always a cause of concern. So instead what we do is we do have some rules. We basically say, these are global variables. They're declared globally. Same with imports. Don't change them. They should be immutable. And we do our very best to complain about it if you change them. So no reassigning of variables. We really don't like stuff like this. Python is a dynamic language. Come talk to me after if you want to circumvent this. You can figure out ways around it, but we do our best to be very much in your face about it if you do things like this. And then I do hear you think, well, OK, Vincent, that sounds cool, but like, what about stuff like this, right? Like, what if I like using for loops? Technically, that also means that I cannot do this. Right? Because I declare, when you make a for loop, you declare I in that for loop. So if I were to running this again, it's going to complain. You're going to go like, oh, that's a bad experience. We do have a convention. If you put an underscore in front of the variable, then we assume that that variable is, I should also do this, by the way. Yep. If you put an underscore in front of the variable, we assume it's scoped to the cell and has no meaning after. So if you want to, it's actually kind of similar to what you would normally do in Python. If you have a variable that you don't care about, you just use the underscore. But you can have named variables that we ignore for cells later, so you can still do stuff like this. Another thing I can also kind of hear the audience think is like, oh, Vincent, that's kind of nice, right? You have reactive elements, that's kind of cool, but when does that matter? Well, I'm importing Marimo over here, right? So Marimo has a UI submodule. So one thing I can load is I can load up a slider. And let's call this slider. Slider equals slider. Slider. This is now a slider I can move around. But from the perspective of this cell, if the value of the slider changes, then I can also say, well, the value of this slider object changed. And therefore, I can also say, well, let's have y depend on the value of that slider. And suddenly, when I move the slider around, you can also see that the addition above updates. So if you have that reactive nature in the cells, oh, we can put UI elements in it, and the behavior is exactly the same. It's still a reactive DAG. It's just that the mechanism that triggers it isn't a code run. It's a UI change. And this is amazing, because I've always felt that like, machine learning has a huge UI problem. Like, sometimes code is not the best way to explore a data set. Sometimes you want something visual. Sometimes you want something interactive. And now we have a way to bridge that chasm, if that makes sense. As long as you assume that cells are reactive and that your code is immutable, you can really go a long way. But way in the back, I can hear this voice that sort of goes like, that sounds great, Vincent, but what if I'm doing expensive compute? Like really expensive compute, something bananas, something that takes a minute or something. Then I don't want like a UI change like this to automatically update all sorts of stuff, right? And for that, I would like to point your attention to 3 buttons at the bottom over here. So right now, and that's also the default, when the notebook starts up, it is configured to auto-run, so all the cells try to run. You can also auto-run when the cells change, and you can also auto-run when a module changes. So when you have a helper file somewhere, when that file updates, we can also trigger the whole notebook to run again in a very reactive fashion. But you can also trigger that to become lazy instead. And now what happens if I change the cell? Colors change, so you get an indication that this cell hasn't updated yet, but it doesn't actually run the cell yet. So we have mechanisms for that use case too. We also have user interface elements. So we have this thing that's known as a run button, and you can use that to trigger a cell run. So there's mechanisms for that too if you want to go with the UI route. But just the native interface in the notebook also has support for this. For the remainder of the demos today, this won't be relevant, so I can just slide around and see things nicely update. But do know if you have very expensive compute that's happening, you have control over this as well. And something that's just kind of good to know. Some of the other utilities that I think are also just good to mention is, I can have my cursor on this thing, and I can kind of see some auto-completion. Maybe I just want to have the full doc string instead. So OK, let's put my cursor here. OK, this is like the full documentation, the full doc string, with some nice renderings as well, and you can see all the examples. So as I'm typing along, you can also see that the documentation can update. So we have some of these modern utilities that you can also use in the side panel, which is also, I think, very nice. But what I'm now going to show you, and it's going to be a bit of a flex because I'm about to demonstrate a library that I made. But let's now say I want to actually do something kind of interesting, maybe interactive and visually. And for that, I want to expose you to this idea of widgets. There is an incredible library called anywidget. The whole world is sleeping on this package. To me, it's the most revolutionary thing in the past 2 years. But there's now finally a standard to make JavaScript widgets that interact with Python across all notebook environments. It works in Marimo, it works in Colab, it works in Jupyter, it works in VS Code. And one of my favorite demos for this is a thing that I made called draw data. So I'm going to say import, or actually from draw data, import the scatter widget. OK. I'm going to hit play soon, but try to think what should happen when I do that. I haven't installed it yet, right? So in your mind, you're probably thinking, oh, that's $sign pip install something command like that, maybe call bash. But this notebook is running inside of a UV environment that's unique. That's what the sandbox flag was for when I started this notebook. So when I hit run now, Marimo is able to detect, ooh, that's a library, it doesn't exist yet. It's also not on the local path. Oh, therefore, it's probably something we got to install. And I can hit install now. You can see the logs. It's also going to install anywidget and all those things. OK, installation's done now. Great. So we can also automatically detect when something's missing, and we just install it for you on the fly. We have UV now. Life is good. So what I'm going to do now is I'm just going to create the widget. So scatter widget just like that. Again, if I want to have documentation, I can do that in this tab. I'm going to do this one extra thing that we currently still require. In order for Marimo to really play nice with these widgets, we have this decorator of sorts. But OK, we now have a nice little drawing widget. Let me just zoom out. So again, the whole point here is that I can just very conveniently draw myself a data set, and I can make the brush like way bigger. I can also make the brush like super thin, so I can do things like PyData. Something I can just kind of sort of draw. But again, this is a widget. Very much like the slider. It's just a very different interaction that I'm doing. So that means that one thing I could do is I could go down here and ask for the value of the widget. There's also a helper method, data as polars. Oh, it detects that polar's not around. It is required. It's going to try to install it. I can hit this plus icon to also get these package extras if I'm interested. That's something you can do manually if you want. I'm just going to say, fine, just install. Polars is really nice because it's just a single dependency. And if I were now to rerun this cell, then we get our data frame representation, which is really cool. So instead of having like a static HTML table, we actually give you a proper widget. And that means that you can do stuff like, oh, I don't know, you can sort ascending and then maybe descending. We also have this search widget. So I can just say, oh, I want to have just a random string that I'm looking for. So let's say A. and then it's going to filter all the rows where A appears in any of the cells, right? So the data frame view, as it were, it also comes with pagination. We also have a nice little sidebar over here where we can get like a summary. So Altair is needed to render the charts here on the summary table. Let's install it. It's been added. There you go. So I also have like a nice little summary for all these different columns, and this is nice because it means I don't have to write a whole lot of code to get an impression of what's in the data frame, which is super sweet. But the thing that's also just kind of useful and nice now is it fits on screen, but it kind of feels like, especially if I have a wide display, that I want to maybe do it differently. So I could go here with my mouse cursor and maybe change something in the settings, but instead I'm going to use the command palette. Jupyter also has this, by the way, but there's like shortcuts here. And what I can do is I can say, well, let's run this app, but in column mode. Because I don't know about you, I don't like scrolling for miles. That feels not ideal sometimes. So instead, I'm going to see if I can maybe get some structure going. So let's make this a bit thin. Let's make like a column on the side here, and like another column on the side here. And what I can do is I can just click and drag this guy, and I can click and drag this guy. Maybe move it to the right. And like a thing I really usually love doing is I can turn this into a markdown cell as well. So there's like usually boilerplate stuff that's happening here. I can also hide the markdown. Oh, let's delete that one cell, but let's make this a markdown cell as well. And this is like more interesting stuff. And then usually, the more you scroll, in my mind at least, like the more you scroll to the right, the more interesting the stuff gets, right? So like even more interesting stuff, even more, exclamation point. And let's hide that. But the nice thing about this is I can really easily show you that as I draw more stuff here, that then the cell on the right automatically updates as well. So if I do a whole lot of orange stuff on the side over here, then you should see the x-axis over here. Yeah, that distribution now changes. You can build your own anywidgets. You can almost vibe code them these days. We're not quite there yet for complex stuff, but I maintain like at least 8 anywidget libraries now that have these widgets for you, so you can do like really fun stuff. Drawing data is one of them. You're going to see a few more of them in this demo, but oh, this is kind of nice. Like I could do code organization and things like that. But what I'm doing now is I'm creating data, and then I'm moving it into a data frame and showing you stuff with it. If this were a more real-life scenario, you would probably not draw your own data set. I've heard of some stories of academics doing it, causing all sorts of fraud, but that's not what we're doing. We're probably more interested in doing proper analysis. So what I could do instead is let's maybe call this a data frame, right? And I'm just putting that into a variable. And the moment that I put that into a variable, there's a few interesting things that happen. The most obvious thing that happens is that I can refer to it. Let me just do that by zooming in. And I can maybe make a chart with it. My favorite library for this stuff these days is Altair, so import Altair as alt. It is a really cool library. It's already loaded, nice. The way you initialize it, you say, hey, I want to make a chart around this data frame, and the marks that I want to add are points, and then I want to encode that such that I think there's an X column, and I think there's like a Y column. And there we go. This is the chart. It's basically the same data as this. It's just one color. It's a little bit boring, but what I could do now is I could, I could just stare at this. But Marimo also has decorators for some of these charts. Because under the hood, Altair is using Vega, which comes with some reactive abilities for JavaScript. It's just that it's normally not unlocked. But if you were to wrap a scatter chart with this Marimo UI Altair chart wrapper, ooh, then we get something fancy. So I could do something like chart equals in this case, right? And let's actually show the chart in this case, right? And what I can actually do now is I can say chart.value. Because this chart, it doesn't look like it, but this chart is actually very much like a slider. I can just select some data, and then the data frame that I've selected is showing up at the bottom over here. So I can select the P from PyData, or the Y from PyData. And we have embeddings now. Embeddings plus UMAP or PCA is amazing when you can actually select a cluster. And the nice thing is it is a bit of a change to normal, but if you hold Command down, you can actually zoom in and pan and do all those kind of good things. We even have, we're not quite there yet, but we're thinking about adding support for Vega Fusion here as well, maybe. That way we can have lots of points here and have maybe a GPU help you out render all of these things. But oh my, this is just so freaking useful. Like, I don't know how often I've had it in my career that I make a chart and then I go, I want to select that subset. I can see it with my eyes. But then you have to write some really weird code to actually get the subset that you need. And maybe there's something about interactivity. This is really fluid and really practical, if you think about it. So like one of the things I really love doing is, oh, there's some data, I've never seen it before, but I need to annotate it for some classifier. OK, let's embed it and then see some clusters. And then, oh, this cluster seems to be about a single topic. Let's annotate them. And then hopefully we see some weird examples appear. And that's all stuff I can do from a notebook now, because I have Python at my disposal together with these reactive elements. And you don't even have to think about the reactivity, because that's just really built in. There are some other things you can do, though, if you have a data frame variable. And I want to work towards that. But the first thing I want to maybe show with that thing in mind, because I have someone who's involved with the DuckDB project here, you'll notice that a cell can have Markdown in it, but we also have support for SQL. And in default mode, like if we don't specify anything, like we have multiple backends that we support, but our best bet is to just use DuckDB in memory. And what you can actually do is you can do things like, hey, select star from that data frame that we have in polars, and let's just select the first 5 rows, and it has to install a bunch of stuff like DuckDB and SQLglot, and it's going to install it, it detects it, super nice. And if I were now to run this, oh, it also needs PyArrow. OK, fine. OK, and PyArrow has this annoying implementation where you have to restart the notebook. That's not on us. That's actually details. But I now refresh this thing. Again, it's set to auto-run. I first have to draw the data set again, because otherwise this chart has an error. And then I have a data frame over here. And lo and behold, I can also use SQL if I wanted to in this particular case. One thing that's really epic about this is that you can write your SQL here and maybe unit test it as well. Like, because this is another thing. This is now dfduck. This SQL statement is going to also return to me a data frame, which, again, did I call it dfduck? Oh, I have to run the cell again. So anything that comes out of the SQL, we can also automatically turn into pandas or polars. Usually, we try to go for polars these days. But we can also like go from data frame to SQL and then go back again quite natively, because it's just a SQL cell, and all the rules are exactly the same every single time that this df updates. Everything else updates, and you can do string interpolation and stuff as well in here. So, kind of nice, right? Like we can kind of rethink the way that we deal with our notebooks. And I'm just going to have a look at my notes to see if I forgot anything that I wanted to show at this section. No, I showed everything here. So, OK. This was like a fun little exercise. But now I want to do something that's a little bit more quote-unquote for realsies. So I'm just going to close this notebook. And now let's go again with sandbox, but now I'm going to do something data.py. Like let's actually do something with data now. Because it's called PyData, right? We probably want to do stuff with data. And oh, it's still set to column mode. I'm going to hit the command palette and set it to compact mode, so it's all fitting on one screen. Shortcuts are amazing. What I now want to talk about is data sources, because usually, all the demos out there use a CSV file, but these days data comes out of a database usually. So can we make some stuff nice for that? We have a SQL cell that's already quite nice, but you still got to make a connection. We have this Explore Data Sources panel over here, and what I can do is I can add a database or a catalog. And there's a little GUI that can kind of help you. There's Iceberg over here. And there's the typical databases you would expect. So there's DuckDB, MotherDuck, ClickHouse, who's also a sponsor of this event. But in this case, because I want to keep things simple, I'm just going to go with SQLite. And I think I called my database db.sqlite. I'm just going to go and add it. You're going to see that the UI basically adds this little bit of code on the side over here. The main thing that we care about is that we have some sort of an engine that we detect being of a certain type. And if I now were to run this cell, I have to install SQL Alchemy. That looks pretty good. And I can see that in my data sources tab over here, db.sqlite appears. And in the main database, there is a Titanic data set. I can hit plus, and it's going to immediately add a SQLite. So this is a different SQL cell. This one is using the SQLite engine, because, again, the data is actually SQLite in this case. Before, we had a data frame in memory, and we just passed that memory on to DuckDB. In this case, we actually use SQLite. I run this. Again, it has to install polars with PyArrow. Let's see if I can run this again without having to restart. I have to install SQLglot. OK, that also makes sense. Fine. Hit run again, and it does work this time around. And this is the Titanic data set. It's here. I can store this as in a variable called df. Let's hit play one more time. And from here, I could do all the tricks that I want to. But the main thing that's important to recognize is that we, of course, care about where the data comes from. So these connections are definitely important. We also have this feature where we detect the local .n file. So if you want to have a secure way to deal with keys in order to make the connection, that is also something we have some support for. So that's something to also keep in the back of your mind. But I think for this modern day and age, the thing that really matters and the thing that really makes it different than what you're probably used to is how much value you get from doing this with LLMs. Because I just want to make one observation on that front. We also have a chat with AI panel over here. And you can connect to OpenRouter, to your favorite LLM. We are basically vendor agnostic. Last week, we also added support for Claude Code, so you can use your existing Claude Code account, connect to it. Won't demo that here, but that's something that we now have in early mode. But the thing that really matters here is I can get some nice auto-completions. So I can do @ and then I can either point to that data frame or that table in SQLite, and this can be part of the prompt. And why does this matter? Well, we can inject the schema. So we can tell the LLM, oh, by the way, these are the names of the columns, these are the types of the columns, here's a couple of examples, and especially if you're dealing with Parquet files or something that Claude Code can just read from the terminal. And also, again, this is the representation in memory right now, so you can make the LLM aware of oh, we've done a few pre-processing steps, this is what the data frame actually is right now, and otherwise the LLM has to guess all of that. But by having this being able to inject directly, oh, we get a lot of stuff at our disposal too. We also have, there's no errors right now, but you can also do @errors to point to any cells with errors in them, and it's going to try to fix it for you. But in this case, just as a demo, make how many people survived the Titanic disaster, I guess we can call it. And it's going to do its thinking thing. It's definitely doing its thinking thing. I could have picked a different model, but in this case, it's even going for SQL. So what I can do, let's just add that to the notebook, and let's just run this. And there we go. It's now doing an aggregation for passenger class. This is very typical Claude behavior, by the way. You ask it for one thing, and it gives you 6 things back. But you can generate SQL. You can also generate Python code. You can also generate visualizations and what have you. That is all stuff built in. But the thing I really want to, I've been doing a little bit of vibe coding here and there, and I just find that if I tell the LLM, here's a bunch of existing polars code or a bunch of existing SQL code, now make the next table, if it doesn't have access to the current representation of the schema, it really has a hard time. So being able to just directly say, oh, here's the memory representation, do something with it, it's super sweet. Another thing I want to point out is that this @ also works for any variable you have in Python. Tables are a special citizen because we know how to properly contextualize that. But if you want to point to a string or a list of strings or whatever variable, we do our best to add some form of context for the LLM here. We try to be clever about it. That's chapter 2 done, I think, because I talked about DuckDB beforehand. What I can now maybe talk about, I think, and it is something I think y'all are interested in, and let's maybe turn this into a markdown cell and demo, something like this. Because I can probably hear you think OK, Vincent, that's great. What is the JSON representation for all of this stuff, right? What kind of Git thing is going to happen here? And the one thing that is different between Jupyter and Marimo is Jupyter will actually try to store the outputs quite famously. So if you have a matplotlib chart or something like that, you will see the base64 representation inlined in the Jupyter notebook. And there's merit to it because you can imagine, well, it means you don't have to rerun the whole thing again. We have the chart that's nice in Git. Marimo doesn't do that. So we do not store the outputs of any of these cells. What you can do is you can go up here and you can say, hey, I want to download this as HTML with all the charts rendered as far as that's possible, right? That's something that you could do. But the thing that we do, and let's just run this one more time, is we literally store this as a Python file. And that comes with all sorts of crazy benefits if you're a Python developer. So let's just open bat, and what was this file called? This file was called something data. So bat something data. Let me just zoom in. Actually, let me just run it again. This looks slightly nicer. So this is what the notebook looks like. We import Marimo. It's an app. And all these different cells are functions. They're just decorated functions, basically. And that's actually kind of nice from a reactive perspective, right? So, oh, we know that this cell has to update. How does it update? Well, it's a Python function. We just run it, basically, and you're done. And you can see that I'm importing marimo over here. You can see down below there's SQL alchemy. There's like a couple of things. You can also see that a markdown cell in marimo is really just a normal Python cell, but just with a single MOMD call inside of it. And there's a very similar thing happening with SQL. So it's really just a string with the MO SQL thing around it. So it's really just Python code. But the thing about Python code these days, which is like really amazing, is we have UV. And you know what UV can do for Python scripts? It can add the dependencies on top. And as I was importing libraries, as I was coding around, because I'm running this in the sandbox mode, we can automatically tell the Python file, like, OK, these are the dependencies that we've just installed, add them on top over here, and the notebook is now self-contained. You don't have to ship a ipynb file with a requirements.txt or anything like that. You can just have one single Python file, and that should be enough to like UV run it effectively. There's also another thing you can do with Python files, actually. It's also just kind of fun and interesting. And like, what I'm just going to do here, is this a fun demo? Actually, yeah, let's actually show that as well. No, let's start a new notebook for that. I'm going to start, yeah, let's just start a new notebook for that. I think that's going to be better. So I'm just going to do like something data, and now I'm going to do something cool.py. So again, this is again going to be a Python file, and again, let's run this in compact mode. And again, I'm going to load marimo, and I'm going to do mo UI.slider now, 1.10.1, and that's a slider. Right, and I can do slider, and I'm going to see the slider appear, and then I can do slider.value times none, and then at the end, I'm going to do Batman, and then you can see no, Batman. Like, it's a super awesome demo. But the thing is, like, this is a notebook still, right? You can see the cells, and there are a couple of these situations where actually the cells don't really matter. And like one thing you could do is you could sort of, we have this hide mode thing for cells where like you don't see the code unless you actually click on it. But another thing you could do is you can also run this in app mode. So a notebook so far has been running in edit mode, which is like a normal notebook experience of cells. But you can also say, well, I don't really care about the cells anymore. This has to go to a business user. Usually they're called Bill, and he has business reasons to use your app. And you can put all of your interactive widgets in here. And remember that data frame widget that I showed you earlier? That also has a download button such that he can copy stuff into Excel, for example. So you can also make these bespoke apps that like take stuff from DuckDB and still end up in Excel somewhere, but you can just make a quick notebook for it, and Bob is still happy, or Bill, or whatever he's called. But hang on. If I now go back to the terminal, oh, I was actually running this, like in edit mode. But another thing I can do is I can also say, well, no, you are able to go immediately to run mode right now. And now, the whole notebook goes away. This is kind of like you're just deploying an app, if it were. And you can put this in a Docker container if you like. And it's really nice and self-contained. And it's really just a notebook. And the notebook can be a nice little web app. It's kind of, it has a similar feeling to me when I tried it the first time. It kind of was like, oh, it's like Streamlit, but I don't lose the notebook. The thing that I've always had a bit of an awkward relationship with Streamlit for was, oh, I have a thing working in a notebook, like the algorithm works, and now I got to duplicate the code somehow, but also make it different here, and then, OK, the Streamlit thing works, then I want to go back to the notebook, and oh, the algorithm's actually broken, I want to fix it, they're going to copy the code again. That's now also gone, because again, it's all just one file with all the dependencies just strictly in there. But this is cool, but I'm still not really showing you that this is a Python file. So I'm going to go back to edit mode now, and I'm going to show you basically one of my favorite libraries that people sort of misinterpret all the time. Who here likes to use Typer? 4 hands, great, OK. Typer is amazing. So, so from Typer, I think I got to import Typer. Typer is made by the folks who also make Fast API. And basically what Fast API does for the web, Typer does for your command line. So it's like, oh, I have a Python function. I'm going to run it from the command line. And Typer just makes that super nice. And I think what I could do is I could do something like, I think I got to do app equal, let's call this Typer underscore app equals Typer. Something like this, right? And then I can do add Typer app. And I got to do command. Yeah. It's, oh, auto-completion is also a feature, by the way. So That's also a thing we have. And I could do something like def hello, name equal, it's a string, so I could do return, or actually print in this case. So print hello, and then plus name. And let's do the same thing for goodbye. Goodbye, goodbye. And a thing I can do is I can basically say, oh, Marimo, I want to get the meta information, app meta. I want to get the meta information from you. And then I want to check the mode. Right now, Marimo is able to detect that it's running in edit mode. You also saw what it can be like if it's running in app mode. So you can actually write the code in such a way that if you're running in app mode, slightly different things happen. But it also means that I can detect if it's running in script mode. And if that's the case, then I think I got to call a typer app. I think this is what I got to do in that case. Let's see if it works. So if I were now to do Python or UV run in this, no, Python something something. Actually, UV run I got to do, because then it will automatically do the sandbox thing. OK, fine. With Marimo. And OK, it's saying missing command. I can do help. Oh, there are the commands again, and I can do hello PyData. Lo and behold, my notebook is now a command line app, because it's just a Python file. And Python files can run as if they're normal Python files. Nothing really crazy is happening there. What's another thing you can do with Python files? Well, let me go back to edit mode again. And in this particular case, one thing I could do is I could say, like, I want to add a unit test. So dev test goodbye. And I want to test that. I'm just going to do assert true, because we're not really, let's return something as well. Return goodbye, because we want to unit test our code, right? So let's actually return a thing here. So then I could do like, hey, goodbye, name, PyData, double equals, goodbye, PyData, and then assert. That's usually what you do. There you go. OK, it's detecting right now that PyTest is missing, so let me just import that, import PyTest. There you go. And if I were to rerun this now, oh, it's failing. Anyway, it's captured some standard output. It's not being equal. Did I make a typo? Oh, I might have to rerun. Yeah, you're right. Ah, there you go, reactive, super nice. So one thing that's also kind of cool is you can, in terms of making this reproducible, right, not only can you add the dependencies, you can also add just your unit test, 10 minutes, got it. But another thing that's also just kind of nice is you can also just go, OK, Marimo, so again, we can also have PyTest now and point that to something cool.py. And it doesn't have, OK, UV run -- with PyTest. There we go. In this case, it's missing typer. So OK, you still have to do a little bit of your dependency thing, and then also probably with Marimo. But there you go. You can use Marimo as a web app. You can use Marimo as PyTest. You can use it as a command. Oh, Marimo is just Python. Like, that's the feeling here. And again, I don't want to make fun of Jupyter or anything like that, because I do think Jupyter is amazing, and it has really made my career possible in the first place. But the one thing I do want to point out is that Jupyter is designed to be multilingual, and Marimo isn't. We just happen to have great SQL support if you're a Python user. That's why we can support SQL very well. But it's really meant to be like a Python thing. And that means we can have first-class support for UV, PyTest, and all those other utilities that we've known to come and love. But there's one extra thing you can do with Python files that's a bit unconventional to do in a notebook, but it's something that I have come to rely on basically all of my web apps today. So one thing I could also do, right, is I could, let's just delete all of this, because we don't need it anymore. Let's just delete it, delete, clean up, clean up, clean up. So let's just say I have this function over here called add. Oh, and I deleted some stuff, maybe too quick. Fine, let's just delete this. Fine. OK, this is a demo. I don't want it to go wrong, so I'm just going to start a new notebook just to play it safe. Import me.py, just as a hint about what we're going to do. So what I can also just do here is I can say, well, let's have a function here, def add, and like number 1, number 2. I'm just going to add 2 numbers together. Business Bob asked for this feature, so we're just going to add it like this, right? We have our function. That's totally cool. You're going to notice that in this case, Marimo is detecting that this is reusable. What does that mean? It means that there's a cell that has only one function in it, and it doesn't depend on anything else in the notebook. If it did depend on anything else in the notebook, you are going to have to add a setup cell. This is a very special cell where you can maybe import polars and really make sure that's globally available. That way, this cell can still be reusable because it's aware of the dependencies. But OK, this file is called importme.py. And this one is called importuse.py. And because it's a Python file, what I can do is I can say from import me, import add, and our enterprise use case is now solved. You can import functions from a notebook. Why is this so useful? This is just, what I'm about to show is a super personal project. Don't go ahead and use this. But I have this memory card thing I'm making for myself, for like flashcards, but for programming things. And a very important part of this is spaced repetition. Like, I practice a flashcard. I don't want to practice it right away after. I want the time in between to make sense. That's very much a machine learning thing. And in order to debug that, I need charts and like logs and charts, mainly. That's the really thing I need. So this web app has like a Marimo notebook in it, and the only thing that that notebook does is export this one function that does all the machine learning things. And if I ever need to debug it, I can go into notebook mode again. Right? And I'm contemplating also making my fast API apps in this notebook now. This is, I don't know if it's a recommended practice or anything like that, but I am contemplating it because it just feels so nice for my machine learning thing to have a chart in the IDE that I can go ahead and use. It's something I really miss whenever I use VS Code nowadays. But OK, so far, everything I've shown you is just features. And features are cool, but it's not really the point that I want to get at. 5 minutes, gotcha. So the point that I want to get at mainly is that we can maybe dream a little bit again. Because if you think about Python, it did all start from the terminal. So you notice that there's just lots of stuff that's like all about the terminal way of working. And like one really typical thing here is like this library I've made called DiceKit. It has, it soon will be a machine learning library too. I'm going to call it DiceKit Learn. But right now, it's mainly just a library that has some nice dice-like objects in it. And it would be nice if the installation was kind of quick, because we're running a little bit out of time. What? OK, does this work? Dice is not defined. Restart the notebook. Restart. OK, there we go. So normally in Python, if you're from the terminal, this is a normal representation of an object. Like characters, that's the way you represent an object in memory. But if this is a dice, I can also say, well, let's make a 6-sided dice over here. And oh, that's actually a probability distribution. Maybe this is a better representation of the die. And what I can now do is I can say, well, what happens if you add 2 dice together? Oh, you get a different probability distribution. And oh, by the way, yeah, I've got sliders. So I can add a slider over here, maybe do something like really fun. I can do like slider and show the slider, and then this die over. I have to import marimo, but slider.value, and then here import marimo as mo, and then run it, and then, oh, I have a slider over here, and when this automatically runs now, oh, everything just updates automatically, and I can think so visual now. Like Python that I knew, like all terminal stuff, it's great, it got us so far, but we can actually start dreaming again now because we can come up with stuff like this on the fly. We can really make things interactive. We can add charts. We can add all sorts of interactions. And you know, maybe as the craziest demo of all of this, another thing that I haven't really been able to show you yet is I have this project called MoLabel. And oh, by the way, Marimo can also export to WASM. So what you're about to see is actually hosted on GitHub Pages. And what I'm about to do is I'm about to plug in a gamepad, because when I annotate my data, I really like to sit comfortably. So you have to imagine when I'm annotating a data set after doing all the interactive things, I basically have a controller now, and I can say, yes, it looks good, no, that doesn't. And then, oh, this needs some annotation or something. There's a web API that can turn text into speech into text, so I can use that from a notebook as well. OK, let's add that. And then a cell below over here just automatically updates with all the annotations that I've added. This is running in WebAssembly, and because it's Python, I can do this virtual thing. So the main thing I want to get at here isn't so much like Marimo's nice, there's features. The main thing I want to get at here is that we should start dreaming again. Like, it's not so much that we understand what we're doing, is that it's more that we are underway to building something better. And I would love to see a larger community take these widgets and this way of working serious, because machine learning still suffers from a huge UI problem, and I do think that this direction has a lot of promise. And I also still love Jupyter, but I do think something about this reactivity is going to be a massive boost to actually understanding the data set. And that's actually a problem we haven't solved in the last 10 years. So, if people want to play around with this gamepad, come talk to me after. Thanks for listening. I have one more minute, but I'm going to give it to the audience for questions. Thanks for listening. I hope this was a useful demo. And the final thing, if more people want to do live coding during talks, I would love to see that more as well. Thank you.
Thank you, Vincent. This was very cool. So we have time for a few questions from the audience. Yes.
Oh, dang it, I forgot that thing.
Wonderful talk. You can show that thing if you want to. But
yeah, I'm listening, but I'm going to show you a thing. Yeah.
The question is, what if I do want to persist data between runs, like not forget the scatter plot that you were drawing? Do you have a pattern or a library to do that?
Unfortunately, that scatter chart needs objects in memory. So what there is a feature that I wasn't able to show. We do have a caching layer. So you can persist the output of a cell given inputs of a cell. Like we have caching mechanisms for that. And then that way, when you restart the notebook, it just fetches things from the cache. But you do need like Python objects in memory to get that thing functional. So we cannot necessarily export that as HTML all the time, because Pickle doesn't serialize for every object in the browser and stuff like that. But caching mechanism is a thing that you're probably interested in. Import. So feel free to ask more questions. I'm just typing some stuff on display while people are...
More questions?
Yeah, more questions.
Yeah, Vincent. It's just curious, are you familiar with Kedro?
Kedro, yeah?
Yeah. So for my work, I use a lot of Kedro, and the way I normally code now is I have IPython open, and I put a bunch of things in Kedro and copy them into my IPython console. Is there any way to integrate a sort of Kedro workflow into a Marimo notebook where you can run nodes and
does
do
Kedro
some
use
debugging and all that?
Does Kedro use Python?
Yeah.
Then I think you can.
Okay.
Because again, this is all Python, right?
Right.
So in that sense, I would have to know more about Kedro to know the ins and outs. But in general, every time that I thought, like, oh, does this work? The main question it usually boils down to is, to what extent can I just solve it with Python?
Right. OK. Something to play around with. Thanks.
Basically. The thing I wanted to mention is I have this library called moHTML that lets you use like Python functions, basically, to define your HTML tags that just render. Any Python object can have a dunder display method attached, and then that object will always be rendered with your own custom code. So you can use custom HTML as well to represent your Python objects. It's a really neat pattern. There's a YouTube video about it. Come talk to me after. I'll show you more about that as well.
We have time for one more question.
Thanks for the presentation. I was wondering how would Marimo fit in the big data ecosystem?
In the big data ecosystem? Yeah. Well, we support DuckDB and Spark and those sorts of things. Like those are just database connectors, if it were. Is there a different concern, though?
I was just wondering.
No, yeah, no, so at the moment, the way it just works is, like usually with Spark, right? Like, oh, I don't run Spark on my laptop, it's somewhere else, but I do send the commands and I get the response back. And to some extent, if you're using MotherDuck, our integration, we do something similar. Like the data in the computer is just somewhere, and this is just your user interface. So that's like the most common sort of quote-unquote enterprise pattern that I've seen. I will make the argument, though, especially if you have tools like DuckDB and Polars around, you can do a lot on your laptop, actually. Like, I wouldn't be that surprised if maybe in the coming age, you just do more stuff locally in a way. So, like, try to look forward to that as well, is maybe a thing I would say.
So, thank you, Vincent.
Cool.